So what I'm going to do now, mate, is I'm going to go through a whole bunch of dislocated information that can show up in the PTS, and also a little bit of stuff about the written test. I'll start and I'll just talk about some things you might have seen in the written test. So there's a little bit in there that says when you're replacing an eyelet, what precautions should you take? And if you remember, it says you should try and sew it onto a reinforced area. So that's an eyelet there, that little clover leaf looking fella. It also talks about pack opening bands. That's what they are. And their purpose is that when the pin is pulled, opens the pack. Okay, that makes sense. And I think it even says in there that you should squeeze these closed with pliers, the pack opening bands, to stop them from accidentally grabbing a line. And it also says, I think the best tool to thread a pack opening band is a bodkin. That's all in the written test, or it used to be if they hadn't changed it. If we take a look, these little things here with a hole in them that has the pin going through them are locking cones. You probably remember it says what's a good method of field repair for a damaged or worn locking cone, and it says rotate them 180 degrees and re-sew. I think that one's still there. So that's what a locking cone is, in case you're trying to figure it out. Now on this parachute, it doesn't really have risers. These large navy snap hooks have the lines attached directly to them. And I think the question, if I remember in the written test, is what prevents a parachute from collapsing if one of the risers becomes detached? And the answer is a cross connector strap. So if we were to look between these two, we would find a loop of tubular webbing or many turns of type 3 nylon parachute cord, and that's what stops it from collapsing, because it transfers that load to the other riser, and in this case the snap hook. So that's all that confusing stuff that's in the written test that you're probably never going to need to remember again after the test. Now if we take a look here, I've prepared this round parachute to dry it. So I've hung it by the apex, and if you remember in the test it says what do you do if the place you're hanging it doesn't allow you to keep the lines off the ground, and the answer is chain the lines. So I've done that just for show and tell's sake. 5 minutes. So I'll head next door and clean up a little, please. This parachute here is a square parachute that's been hung to dry, and we're using PD's method. We've hung it by the risers. Now if this thing was sopping wet through, the water would very quickly start to drain through the fabric, and in almost no time at all it would have drip dried. This stuff doesn't hold water very good. And you can kind of move it around a little bit. That'll help get the parachute to dry. And you can put a fan on it. That obviously will speed up the drying process if you just move it around a little bit in that wind. But you should never put direct heat on it. It's okay to put a heater in the room, but you don't want to apply it directly. Now the reason you hang it this way initially is it will deform less, because these locations are where the parachute is supposed to take the load from, the line attachment point. Now once it's fully finished drip drying, which again happens very quick, and if you put the fan on it, you could be looking at only 10 minutes or so, especially out here in summertime. At that point, if you wish to, you can hang it by the tail. Now I'll warn you, if this is a zero porosity parachute, the only way you're going to get the water out of the cells is to hang it by the tail and let it fall out, because they're plastic. It's in plastic bags basically. The correct temperature in your pack-in/drying area is 60 to 85 degrees Fahrenheit and 30 to 60% relative humidity. It's according to Dan Pointer's parachute manual. You might want to remember those numbers. Once your parachutes are completely dry, you can do whatever you were going to do with them, inspect them, pack them, etc. But the rule does say you must air a parachute until it's fully dry. There's no time limit. They don't say an hour, 5 hours, 2 days. It's until it's fully dry. Any questions on that? Awesome. What I'll do now, because it's convenient, is I'll take this down and we'll take a little look at what bias construction is. Throw this up on the table and get a quick look at it so we can figure out what the heck I'm talking about. Thank you, sir. Good stuff. So I'll take a quick look at this here parachute. And I'll talk a little bit about some of the names of some of the parts, just so we can get a feel for what's going on. So this is a round parachute, and right now we've stopped the apex from moving around over at that end, so you can take a look at it. And round the apex there, that little band, that circle, is called the upper lateral band. And then the seams that come from the apex and go to the lower lateral band are called radial seams. If we looked at this from above, they would look like spokes on a wheel. They're radiuses, radial seams. They come from the center to the circumference. That's another name for this, is the circumferential band. So I've got an area of parachute now that's outlined by two adjacent radial seams and an upper and lower lateral band. And this one also has the number 19 on it. So this whole area of parachute is called a gore. Same as the big lad that lost the election in 2000, Gore. I'll work with you because my accent's a bit funny. And I've already said this has a number 19 on it, so we know that this is gore number 19. Now that can be useful for a couple of reasons. One, you can use it when you're assembling the parachute to identify where the lines go, because the line that's next to the number is also 19. So this is line 19 and that's gore 19. It can also be useful when you send it to me and tell me there's damage in gore 19 at the lower lateral bend. All very helpful. Now if we come in close and we take a look at the weave of this fabric, you'll notice that if I drew an imaginary center line down the middle of this gore, that the weave of the fabric is running at a 45-degree angle to that. This is called bias construction. Not biased, there's no T, it's bias construction. I think that's still a question on the test. And just for your knowledge, these seams that run diagonally are called diagonal seams. Very efficient definition there. What I'm going to do now is prepare this parachute for extended storage. Now, extended storage is when you store it for more than 180 days, because that can be just a normal repack cycle. But if you're going to store it for longer than that, you would want to first of all unpack it. Well, we're ahead of the curve on that one. This one's unpacked. I'll just take it off this suspension device. Wow, nice one. And then you can bring the canopy down like so, just to keep it organized. Roll it up on itself a little, and I've already left the lines chained up. Now if there were a deployment device on the parachute, you would remove the rubber bands. Rubber is a naturally occurring product and it will decompose over time, producing this very sticky, grubby, nasty, icky stuff that I charge a lot of money to take off your lines. So just remove your rubber bands. As far as the container goes, if it has an AAD in it, remove the AAD, because as we've all seen from storing old flashlights, when batteries get old, sometimes they leak, and that could cause damage to your container or any of the other stuff here. So I'm now going to take a bin, and I'm going to put my canopy and lines in the bin, thus. And to the extent that you can, you want to separate off the metal work from the canopy and lines. And I say to the extent that you could, because if this was a square parachute, we all know that in a square parachute in certain locations there's metal work that's in there, and we're not going to unpick it and take that out if we store this. So I've now done what I can to keep my canopy and lines away from the hardware that's on the container or in the spring. Now if you look in Dan Pointer's manual, it'll tell you to put this in a hermetically sealed container, something where the atmosphere can't come in and out. I actually think that's a very bad idea, especially for you kitty cats that work in very humid environments, because if you're somewhere where there's a lot of liquid moisture, a lot of moisture vapor, and then you close this up and seal it and the temperature drops, that will become liquid moisture. It'll stop being moisture vapor, and then that water could cause corrosion and other damage and molds, etc. So you're actually better off letting air circulate through the container. The ideal place in your house for this is in an airing cupboard if you have one. One other precaution that you can take if you're storing it in a particularly humid environment is you can add naphthalene flakes, or as they're commonly known, mothballs. And then you just put it in a cool, dry place out of the sun. When I ask that question, a lot of people tell me that they put it in a cool, dry place and they forget the out of the sun bit, which for me in the desert here, a cool, dry place is the driveway for about 5 months of the year. Not a good idea. So remember, cool, dry place out of the sun is where you would store it for an extended period of time. Now if you were storing a square parachute, you would rigmarole it. Now there's no absolute formula for a rigmarole, so if you're one of those guys who likes to argue and say that everybody did it wrong, chances are they just did it different than you, but I'll let you worry about that, I'm not going to. All the other rules are the same, so it'd be an extended period of time, it'd be more than 180 days. If it was going to be somewhere where there's high humidity, you'd add naphthalene flakes, mothballs, and all I'm going to do now is take my front risers in one hand and rears in the other, just like old-fashioned flat pack, and I'll throw this down and somewhat lay it out. There we go. I'll spend a bit of time tidying it. I apologize, my back is not doing well today, so I look really demented. Perfect day to make a video. And now I can just bring my D lines on top of my C's, drop the tail on top of that, fold in the A's and B's like so, and it just makes it incredibly manageable. Plus, when you take it out of the bin, it's better than it being all tangled up in a big old snotty mess. Nobody loves that. And now I'll just chain the lines. And I do the same with this that I did with the round. If it had a container attached to it, sorry, doing that wrong, chain the lines. If it had a container attached to it, I'd put the canopy and lines in my bin first, and then put some paper or fabric or towels or something to separate off the container and lines, and then put it in a cool, dry place out of the sun. Pretty straightforward. So that is how you'd store equipment for an extended period of time. We'll take a walk this way now. So first of all, I'm going to talk a little bit about how to wash a canopy. Now I think one of the questions used to be, which canopy can you wash if you absolutely have to? And I found that word in one of Dan Pointer's parachute manuals, and he said round parachutes. So I suppose a good answer to the question of which canopies should you wash if you absolutely have to is round parachutes. But the reality is, dirty parachutes are the ones you'd wash if you absolutely have to. On that note though, you want to wash a parachute to the minimum extent that you can. So if you can get away with it, if you've just got a small section that's dirty, use an embroidery hoop. I know you fellas all have one at home. They come in a few different styles, doesn't matter which one you pick, but it allows you to isolate an area of material that you're working on, and in this case it's got grease on it, which I would still say is one of the more common things we see from where a parachute maybe didn't get handled well and it came through a door on your car and got a bit of grease on it. If you have any contaminants on your gear, you always want to check with the owner's manual for guidance on how to clear it. Most of the major manufacturers, PD, UPT, Sunpath, that kind of thing, have very good guidance on how to approach this. If that doesn't work, go to CPS's website. Then the military stuff is absolutely chapter and verse on how to do it. It's very useful. So what I'm going to do now is take this grease off of this piece of parachute. I'll take a couple of paper towels, and then I'll take a hydrocarbon, in this case rubbing alcohol, and I'll put it on the grease. And what it does essentially is it dilutes that grease, because grease is also a hydrocarbon, and it now dissolves it, and it allows me to take most of that grease off. Now, if it still didn't get it enough, or if it was something else I was dealing with, grass stains, mud, dirt, then I could use a mild detergent. Now, here in America we typically use Woolite as that mild detergent, but frankly the thing that they're really after is make sure it's a non-bleaching detergent. In Europe I think you'll often find a detergent called DAZ, D-A-Z, that does it, but just check your instructions, just so you know. The vast majority of detergents now don't have bleach. They've found environmentally more friendly ways to make detergent. So I've done 100% solution of detergent on this area, and now I'm just going to rinse it off, and then this way the only piece I got wet was the area of canopy that was dirty, and I washed it in medium warm water, nothing too hot. And then I just let that dry, or I could put a fan on it and dry it more quickly that way. Now, if you do have to wash a whole canopy, take a big plastic bin or use a smooth-sided tub, something that won't snag it, and make up a mixture of warm water and a non-bleaching mild soap, and then put the canopy in there, let it soak, and agitate it only to the extent you need to remove the stain. If you over agitate it, it will dramatically increase the porosity of the fabric. That is to say, it will become more porous. For those of you that may or may not remember, when canopy fabric is made, it comes off the loom, then it goes through two giant rollers that are heated, and they compress the fabric, and what that does is it compresses the weave and makes it less porous. But now by putting the parachute in water, the water gets between all those little fibers and it puffs out, and then we're going to remove the water with a fan and hang in it, and we're left with a parachute that has bigger spaces between the weave essentially, so it's now going to descend faster. So you would really want to be very careful if this was, for instance, on a student canopy or a less experienced jumper's canopy. You might want an experienced guy to go test that, just to make sure that you're not going to get yourself or somebody else hurt. So if you can, avoid washing canopies and lines, but if you have to, wash them to the extent you need to. And you can wash lines if you need to. Same process, mild soap and water, a bit of a soak, agitate to the extent you need, and then remove them. As far as rinsing goes, you rinse a parachute to the extent that you need to, so that the water you're rinsing with no longer has soap bubbles in it. Just keep rinsing with fresh water till all the bubbles are gone. We'll now talk a little bit about washing containers. Try and avoid it. Use a stiff brush if you're just taking off mud or dirt on the outside, but if you absolutely have to, strip the container down. Make sure you take the AAD out. I don't care if it is waterproof or not. Make sure you remove the data card. Take off everything you can. And then anywhere that there's hook Velcro, blanket off by putting pile Velcro over it. And then again, take a nice tub, smooth-sided, warm soap and water, drop the harness container into it, let it soak. Typically I find that if we're doing that on a tandem rig, it might take a whole day. There's tons of grease around certain areas where the neck is, or where the instructors touch the handles on every jump, which is awesome, but it also leaves a lot of dirt behind. So you might want to hit that with 100% solution of the laundry detergent to try and break that stuff down. You typically get about enough DNA out of a rig to make 2 whole tandem instructors, so give it a good soak and then hit it with a brush. It takes me about 45 minutes to an hour to scrub a rig. It's really tedious, don't do it fast, get every aspect of it scrubbed. What you can do then is put it into a mesh dive bag, tie it off, and before that even, I should have said, on anywhere where there's metal work, like on the 3 rings, take rags, shop towels, and tie them through those areas so that as the parachute's being washed, they don't destroy the harness by pounding on themselves. So you're going to put the harness container in a dive bag. We've prepped the metal work, we've prepped the Velcro, and then put it in a front-loading washing machine. Don't use one of those top loaders that has like a beater bar, because it can do some serious damage to your gear. Put it in a front loader if you don't have one, most laundromats do, and put in jeans or towels or some other heavy-duty stuff so that the thing isn't just pummeling itself to death in the drum. Run it through a cycle. The great thing about that is it does a magnificent job of taking away all the detergent and frankly most of the moisture. By the time it's spun it, that thing is doing pretty good. And when you take the rig out, hang it up, place it again like this so you're out of the sun, don't just leave it in the sunshine, and put a fan on it. And then for any of the metal work, towel dry it, otherwise on stainless stuff you typically get water spots. On the cadmium stuff you'll start getting some corrosion areas. So towel dry it quickly, or take a hairdryer that's on the medium setting and just kind of get that area dry quicker than the rest of the rig. Now I did say earlier, make sure that your solution is mild soap and warm water. If you wash a harness in overly hot or overly soapy water, it will remove the resin treatment from the harness. So it will feel fuzzier afterwards and it won't be as easy to sew it. The resin treatment helps the webbing to be stiffer and it's easier for us to work and to use. So don't go too crazy on the heat or the amount of detergent. Another thing on containers, if you're spot washing areas or if you're using any exotic chemicals that you find are discussed in the manuals that you've looked at, be careful not to use a chemical that's going to damage a stiffener, because some of them can weaken stiffeners or create spider cracks or just generally degrade them. So be careful when you read that instruction. If you want to come in a little closer, it's going to get noisy, we'll deal with it. One of the questions on the written test is, what does a red stain on a harness indicate? And the answer is acid contamination. Now I got a little bag of goodies here. This was black webbing, and there was some other Coduras and Parapacks I put in here just for my show and tell. And I took about the equivalent amount of battery acid as the space it takes to fill up about a quarter, just the coin a quarter. What I'm going to do now to test for acid, is take some distilled water and I'll put it on my black webbing, and I'll take a piece of blue litmus paper. Everybody remembers from high school science. Blue litmus paper in the presence of acid will turn red. I've been careful so far not to touch this, as hydrochloric acid is pretty nasty stuff. It's a good way for you ladies out there who need to get rid of an ex-husband, just dissolve him in this, it doesn't take too long. That was a joke, please don't do it. A little bit Breaking Bad. So I'll take my blue litmus paper and I'll touch the area I just wet and we'll see if it changes colour. Hey presto, it turned red. That means we are in the presence of acid contamination. Now I think that the written test still says that you can remediate this by putting ammonia on the harness. Don't do that. If you've got acid contamination, it's all over, kids. Suck it up, throw that bad boy away, you're finished. Next thing I'm going to talk to you about is Velcro, or to give it its real name, hook and loop fastener tape. Let's take a walk over here. And we're going to be over there. You're awesome. So hook and loop fastener tape, or as we know it, Velcro, is becoming less and less common in our business, which is whatever it is. Got two versions here. We've got the pile version, the fuzzy stuff, and then we got the hook version, the stiff stuff. If you ever want to test how good your Velcro is on a rig, let's say I wanted to test this hook, I'd take new pile and I'd put it on there. If it stuck well, I'd know the hook was good. If it didn't stick worth a damn, it means it's weak. And vice versa for the pile. I'd take a piece of hook and I'd test the pile in the same manner. Now you'll notice this piece has been cut lengthwise. That's a reminder for me to talk about it. Never cut Velcro lengthwise or it'll fray out. Only cut it across its width. Don't be cheap, buy the right sized Velcro. Now when you attach Velcro, you always want to put it into the same location that it was on the rig originally. So in this case we have the hook on a riser cover and the pile on the yoke, and then the pile on the riser cover here as so. Now the reason they put it this way most likely is they don't want this hook aggressively abrading any of these areas. And you'll also notice they've put a bigger pile landing pad than the little piece of hook they've got aiming for it. That way they know you get all the hook and you don't leave it to abrade. So a good answer to why you would never change Velcro from its original installation position is that the manufacturer did that for a reason. If you need another reason, it's because it's an alteration, and don't do it. There you go. Now a precaution you can take when you're applying Velcro that's in excess of 1 inch wide, which this is about an inch and a half, if you're putting Velcro on that's bigger than that, you can do an additional row of sewing for each additional inch. So if this is 1 1/4 to 2 inches wide, you can put an additional row in. Now, that's a great answer in theory for a oral test, but in practice, leave it the way you found it. So if this was an old Vector 2 on the riser covers there isn't an additional row of stitching, so don't put one there. But that being said, nothing wrong with manufacturers that have chosen to do that. Now if you get Velcro wet, it doesn't hold as well. At some level the moisture works as a lubricant. But when it dries out again, Velcro will return back to its normal strength. Also, if you get Velcro hot, it becomes weaker because the little hooks, a great opportunity for me to do this, the little hooks become more relaxed and it doesn't hold as well. But as it cools off again, it will start to grip more tightly. And then a word on wet Velcro: if Velcro gets wet, don't let it freeze, or if you do, don't jump the rig until it's thawed. I believe there's more than one person been found dead under an object who's done that, so let's not add to that body count. Thank you very much. There is a type of Velcro called one-way tape, and on one-way tape, instead of all the hooks being in a random pattern, they're all aligned the same way, and it can hold up to 10 times stronger than regular Velcro. So if you have it in your material supply, don't mix them. Make sure the one-way tape doesn't get mixed up, because you could have some pretty difficult situations as a result of it. The only place I've really heard of it being used is in static line applications where they need extra pull force. That's hearsay for me. I've never touched the stuff. Moving on. I'm going to take a quick look now at fabric strength test. Now PD require us to do this whenever we find a suspicious area on their parachutes. They say we should do a fabric strength test. And the test we do is called a PIA TS 108 non-destructive tensile strength test, which can be a misnomer because I've certainly destroyed a few parachutes doing it. That test originally came about in the 80s when some parachutes were found to have acid in the mesh. That acid weakened the adjacent ripstop. We don't really care if all the mesh falls out of a parachute, so what? Air passes through it. We do care though if the ripstop is weak, and the story was relayed to me that it was tissue thin and crumbling, after a repack cycle. That was about 20th hand, so be careful quoting me on that, that's hearsay. But either way, you would want the fabric to be strong enough. And if you go through this TS108 non-destructive tensile strength method, which is available online, it'll tell you where to do the test on a round parachute in relation to the mesh vents. It's the adjacent F111, and there's 3 different types of round setup. It shows you which clamps to use. They're commercially available clamps that have rubber face jaws, and one face is 1 inch by 1 inch. The other face is a little bigger, so that you've got a landing pad, and you'll have to use a calibrated scale. That's a good idea, otherwise you won't really know how much force you're putting into it. It also talks about how to mark the test area afterwards so that someone doesn't retest that specific area. I'm not going to get into that because you'll have available to you this publication, but I want to run through the mechanics of how to do the test, and I'm going to do it on this scrap of fabric here. So I've made a little jig here, and it's 3 inches long by 1 inch wide, and I'm going to align it somewhat with the weave, not off at a funny angle, somewhat with the weave, and I'm going to mark little L's in each corner. It's totally okay to do this with a soft tip permanent marker because you do want people to know that you tested it there. I'm now going to try and clamp down on my marks, and you want your clamps 2 scoops of tight, because if they bounce along and the fabric slips, it can cause damage. We might damage it anyway, but we want to damage it for the right reason, which is because it's weak, not because we're incompetent at testing it. I'll put a big stirrup on this one. Go. That allows me to immobilize it, and I'll take my scale, and if I were doing this on a round, I'd pull 40 pounds of force for 3 seconds. If I was doing it on a PD, I'd pull 30 pounds of force for 3 seconds. So we'll go 40. 1001, 1002, 1003. Beautiful. Now you can inspect the area you've just pull tested, and you want to see if the fabric has ripped, or if any of the fibers have pulled apart, or if it looks excessively damaged. It is reasonable for it to have stretched a little bit. You've just put a lot of focused force through a small area, so it's slightly bowed here, but the fabric is actually in excellent condition. Now, another thing that typically accompanies the fabric strength test is an acid mesh test. Now, this was part of that service bulletin that I was alluding to earlier. Actually, it was an airworthiness directive from the 80s, looking for this acidic mesh, and it was only on this style of mesh, the Marquisette netting. And what you do to test that is you take bromocresol green, it doesn't matter too much, bromocresol green, and you fill the pipette by, I should say the eyedropper, just by squeezing it. Take a little bit of the test chemical up into the eyedropper, and then drop it onto the area of material you wish to test, and put something absorbent below that, just so you don't make a big old mess. I don't want to actually touch the test itself. There we go. Now, initially it should be blue if the area is not contaminated. Now, if it is contaminated, it'll turn yellowy green or greeny yellow. You guys can fight about which color it is. If it doesn't change color, if it stays blue after a reasonable period of time, let's say 15 minutes or so, then your area is not affected. Now, it is possible that due to environmental factors, this will show a tinge of yellow or green over time, because in the air we've got nitrogen and carbon, and when they hit the moisture they can become carbonic acid and nitric acid. And please don't beat me up, I'm not a chemist, so if I said that a bit wrong, send me a message so I can edit that out. But simply put, you should reasonably expect it to stay blue for at least for 15 or 20 minutes, just so you know if you're doing this test and it is a affected piece of mesh, it changes pretty quick. It won't leave you with much doubt. Next thing I want to talk about is how to finger trap a section of coreless Dacron line. That's one of the questions on the PTS, the Practical Testing Standards. So I'll take some Dacron here and I'll cut myself a length. And I think it says have your applicant demonstrate how to put about a 1-inch loop in it. Now the first thing you'll notice there is I just prepared this by cutting it at least a 45-degree angle. And I think the written test still says scissor cut, but what they really mean is don't hot cut it. Because if you hot cut it, you're going to leave a melted plastic edge, which when you trap it inside is going to abrade the line, and then even worse, it acts as kind of a dull plastic knife and it will damage or destroy that piece of line. I'm now going to use a wire fid to insert this. There is another type of fid, which is a needle fid, which works in a slightly different way. You can wind the material into it and insert it into the line. I think wire fids are probably about the most common way of doing this now, and you can make them for free. Just grab yourself some piano wire and a piece of wood and hey presto, you've got a tool. So what I'm going to do is bring my fid into the center of the plies of my material here, and I'll move it to about there. And I'm eyeballing this just so you know, guys, there's no absolute numbers here. It says approximately a 1-inch loop or something to that effect. And as I put the little bitter end of the line into the tool, I'll now suck it into the center of the plies. I'll try and be careful not to close up this eye, as that defeats the purpose obviously. And you go at the speed you go at, and don't twist your loop up, keep it running free. You don't want it turning into something that looks like a Mobius. I'll just do that so I don't close it up, and now I'll back feed the line to give me about a 1-inch, about a 1-inch eye, about like that. Now the next thing I'd do is I'd secure this using either a bar tack or a zigzag, and I'm going to put the bar tack close to the insertion point, so right about there. And I will tell you this, I've seen them where there's just about a 1/4-inch gap, and even that little bit that allows it to chafe, particularly on cascade insertions, I've seen it cause the line to degrade in that area. Now I'll be fair, I work in about the worst place in the world as far as abrasives and heat. So you might not suffer from it in nice places where you've got grass. But anyway, just for good technique's sake, try and put your zigzag or your bar tack close to the insertion point. Now the reason that a bar tack or a zigzag is preferable, if you remember from the written test, it says that they're preferable because they allow for seam elongation without breaking the thread. So if you imagine this as a section of zigzag, it goes up, it keeps going. So this is a zigzag stitch. If this line comes under load, it can elongate without breaking, whereas if it was straight stitch, boom, it could break. Now what I told you is a little bit of a lie there. It's a good lie for the oral test, because it is still true to say that zigzags and bar tacks do provide greater seam elongation without breaking the stitch. But you've probably noticed on some of your high performance modern stuff, Petras, I'm going to get the names wrong. Anyway, some of those crazy flying machines that you guys are out of your minds with, they have started using straight stitch. It's mostly on a type of line that's an aramide line. It doesn't stretch, so it's not a factor. We'll stick with the same answer for the oral tests for now. Let's say it's, or the written test I should say, does say zigzags and bar tacks provide greater seam elongation, so we're going to go with them. For now, wonderful. Please don't call the manufacturers when you find straight stitches and bitch them out. If you do, do not use my name. I don't want that done. So I'll throw a bar tack or a zigzag into this now. I think I'll do a bar tack, it'll be quicker. So we'll take a wander this way. This is an old mechanical bar tacker. It's a 42 stitch bar tacker, which is the one you'll need for doing work on lines. And we'll just try and get that stitch where we've said we want it, which is close to the insertion point. There we go. Just trim her out. Not bad. So that would meet the requirements of the PTS question of how to make a 1-inch form loop in coreless Dacron. If you were sewing this in on a zigzag machine, typically the length will be 1 inch and it'll be 2 passes. And the stitch density typically on a zigzag is 7 to 11 stitches per inch. I don't want to get lost in that right now. Some common types of line that are in use, as you probably know, you've got nylon, you've got polyester, which is known as Dacron, you've got spectral line, also known as microline, and then you've got HMA, Vectran, and Kevlar. So you've got a lot of lines to choose from. If anybody asks you to come up with some names, there's no shortage. And you probably will see most of these on a daily basis on your jobs, and they all have different qualities. People often ask me, why would I want one line over another one? And it's because they all do slightly different things. Some of them have more elasticity, but bigger bulk. Some of them maintain a great dimensional size, but they don't show any wear and tear. So there's lots of reasons for selecting different lines for different applications. And I'll let you guys fight about what's best. When lines are manufactured initially, they are manufactured under tension to ensure uniform production. Now, most of the line that we buy in this industry is pre-stretched and heat set, but even with that, the stretchier lines do have to be put under load for a while before you can get an accurate and consistent measurement. So just to recap, remember the name of the tools: FIDS, type of stitching, bar tack or zigzag. Prepare the end of line for insertion by cutting it at a 45-degree angle with either a knife or scissors, but never hot cut. Moving on, we'll take a little look now at grommets. There's 2 different types of grommet in use in our industry. Plain grommets, which are these, and you'll see these on your Sigma rig in the reserve tray where the closing loop is threaded through, and then spur grommets, which you'll see just about everywhere else on all the other rigs. Now, spur grommets have these little teeth on them that help them lock into the plies of material. Plain grommets don't. The reason UPT use them in that location is there's a big chunk of aluminum there, and these teeth, they're not going to make it. Now, in fairness, some of the manufacturers have now started using spur grommets even when they are setting it into metal, because the teeth just collapse. So what? You end up with a good grommet still, and they don't have to stock 2 different sizes. And frankly, it's easier for us in the field as well, so I'm grateful for that. The only grommets I'll have you play with if you're here are size 0 rolled rim brass spur grommets. Now, on your rigs, they're mostly stainless steel grommets, but if you use them, they use more expensive tools to set. And because I've been made sad enough times by people being careless and damaging the tools, so you can see this face has been badly damaged, and on this one the centerpiece of the punch has been snapped off. So I'm going to do the brass ones because I can use cheaper tools, and believe it or not, no one has ever broken a brass setting tool. Wouldn't you know it? My luck, but they couldn't help themselves but break the other ones. So we'll take a quick look now at how to prepare anything to put a grommet in. So the first thing I have to do is select the appropriate hole punch. In this case, I'm going to put a size 0 grommet in, so I'm going to select a size 0 hole punch. Now, the correct tool, I think, in the written test for hitting your set with is a rawhide mallet. I have one for show and tell. They're very expensive, and I'm not going to say that they're great. I like this. I just use a cutting board, a soft board, and put my punch wherever I'm putting it, and then I just bring down the arm of the press and push it to the extent I need to cut the hole. And for those of you out there that drink occasionally in our industry, you don't get quite the same headache from a big banging noise, which is nice. So I've punched a hole, and now I'm going to set this grommet using a fairly ghetto method, which is to say a hand punch. So I'll take my grommet and I'll place it through the material that I'm going to set it in. I'll then put the die where I want it, drop my grommet on top of that, Now put the washer on top of the material. Put the punch in place, and I'll be careful that the punch isn't off at some crazy angle. That's what snaps that centerpiece. So I'll try and keep it vertical, and then I'll just bring this down. I'm going to deliberately underset this grommet so we can take a look at it. So if we take a look, we'll see maybe that the grommet has not sat flush. I can still see the teeth. And you also want to see if the rim has fully rolled, which it has not yet. So I know that I've underset this. Now that being said, you can overset a grommet. If you put too much force on it, you will split the rim or scar the grommet. Now that being said, about 1 in 10 typically do split anyway, because at some level you're trying to get a fairly cold metal to roll. So don't be too shocked. If you split one, you just take it out and try again until you get it right. So this time we've now got the washer so that it's flush in the fabric. I check both sides, make sure it's not scarred or damaged, and that the rim is not ripped and doesn't have any cracks in it. So this is a good grommet. I'm now going to take it out. Now I think the correct answer for the written test is the best way to remove a grommet is by prying. That's a good answer. I'm now going to show you what I found to be useful in the field. You can drill them out. The only problem with that is there's a lot of heat generated, and you want to be careful that you don't melt the surrounding areas. On a brass grommet like this, or for that matter other grommets, place it in a vise so the washer side is facing you. Now the grommet is always necessarily going to be bigger than the fabric it sits in, so you shouldn't have any problems with damage in a flap doing this method. You can now take a punch and a hammer, and what I'm going to do is just roll that rim in the opposite direction, and then I'll try and get behind the washer and give it a tap. And I should have deformed it sufficiently now that I can remove the grommet. Now, if you were doing this on a test, you would be graded on safety. So if you need to wear gloves or something so you don't hurt yourself, feel free. I'm going to risk it. I'm going to use my pliers now to remove my grommet. There we go. Now if I wanted to remediate this hole, I can sear it, hit it with a lighter or a soldering iron, or I can sew around it. And what the sewing does is it tidies up that edge and it creates a little bit of shrinkage, which tightens this up nicely. What I'm going to do on this is a little bit of both, because I kind of wanted to impress it in your mind. Not because you need to, but just because I want you to stick. So I'll take the soldering iron, I'll just lightly cauterize that hole. Or, get ready for this. You can zigzag around the hole. Take it slow, by the way. It's not a race, and the purpose of this zigzag, as I've already said, is to kind of shrink up the hole because of the shrinkage that sewing naturally causes, and also just to tidy up those frayed edges. But if I can, I want to be able to hide the stitches under the washer when I'm finished. There we go, that should do us. We'll pull that out and trim it out. I've used a contrasting color here obviously so it shows up better in the video. You are more than welcome to use something that blends better than that. I'll now reset a grommet in that hole. This time I'll go a bit more Cadillac and I'll use a machine. Now, I haven't calibrated this yet, so I don't know if it's going to be too much or too little, but we'll find out. Now in this one you put the washer in first, then you put the material in and you slide the grommet over the post, and now you just kick it and see if it set it. So it should be flush with the material, nice, and the rim should have rolled. How about that? Now a few last points of things that you need to study. So the fellow that writes the written test is not a rigger. He's an English major who works for the FAO, that's what I've been told. So they give him a ton of books and tell him go write as a test. And one of the things he's latched onto is this awesome diagram that talks about reference lines and plumb lines and chord lines. Now I'm not going to pretend that I really use this, because I don't. I fix parachutes, I don't design them. Look at this diagram and ingest it before you take your written test. Another thing that's cropping up is a discussion of I-beam and T-beam construction. Now most of the parachutes we jump in this day and age are constructed as I-beams. And what that means is between two line attachments, so I'm looking at the front of a parachute now, that's a line attachment point and that's a line attachment point. So that means these are loaded ribs, the load being my fat butt's weight going through a line attachment and into the canopy. And then between them we've got a skin here, this is a bottom skin, and then a skin here, that's the top skin, and then a non-loaded rib, the guy you see in the middle between two line attachments. So we can recognize an I-beam because it makes this kind of I shape, there it is. And then the skin, skin and rib come together on the top, skin, skin and rib come together on the bottom on a loaded rib, and then on a non-loaded you've got the skin, the rib being sewn onto the skins rather than into them. I'm sure I made that confusing enough. Now let's take a quick look at another thing they've latched on, which is interlocking T-beam construction. This is slightly different. Now the bottom is basically the same. You've got a loaded rib, a skin and a skin coming together, rolled into a seam, then a non-loaded rib that's just sewn onto that skin, and then another loaded rib with a skin coming together. But on the top it's offset by half a cell. So here the skin and non-loaded rib come together and they're rolled together and sewn together, and that's what gives it this T shape, if you will. Good luck with that. You'll have to look at the diagrams a few times to get your head around it. It is confusing, but it shouldn't be. It actually starts to make sense after a little while, so take a look at that. Done.